Okay, today is our review day for the test on trig identities, and I thought I would give you a little bit of practice on what you learned yesterday, which were those difference and sum identities. Problem number one is a sum identity. It's the one where you have alpha plus beta. That little dot's annoying me, so I'm going to get rid of it. There we go. Okay, and that can be found on your sheet. You'll have the sheet. You aren't expected to have that one memorized. I think it's sine alpha cosine beta cosine alpha, sine beta, the plus in between. But anyway, you can look it up on the sheet. Make triangles based on this info here and here, and here and here. That'll be two separate triangles. And then you should be able to answer number one and number two. I'm going to give you a minute to work on that. And tomorrow, you know, you're going to be working in groups on this. Might as well get used to how do you do math problems in groups. Okay, so I'm going to get you in a group here for you to try these two problems. So I'll resume once we've had a chance to finish those. So if you're trying this at home, pause me and then resume again once you think you've got them. Again here. So I hope that this first one, you said this info is telling me alpha, and that is saying that it's in quadrant. Well, all students take calc. Sign's positive in these two, so it can't be there. Tangent is also supposed to be negative, so I want to draw this first one right here. And did you say 1 and this, be careful now, 1 and 8 are the sides? No, negative 1 and 8, how about that? Okay, good, and is there another side? And I had a lot of people get this wrong on the test. I think some people think you just automatically do the other two sides squared and added together. You don't. It's the other two sides squared, yes. 8 squared is 64, and 1 squared is 1. But is it 64 minus 1 or 64 plus 1? In this case, minus, because we have the hypotenuse already. If we had the two legs, we'd be adding them. But this is the longest side already. So we got to go 64 minus the 1, and 1 squared is 1 still. So 64 minus 1 gives you 63. Raise your hand if you had square root of 63. Okay, good. And a lot of people on tests would have had like square root of 65 there because they were adding it instead of subtracting it. Okay, next thing. If I wanted to do the other triangle, that's this blue one, and it would be tangent is opposite over adjacent, 2 over 3, and this is where beta is, and I should probably in green put here that this is where alpha is. And then, why did I draw it there? Because tangent is positive in two places, but it said it had to be between pi and 2 pi. Here's pi, here's 2 pi. Had to be in that zone down here, so that's why I had to do it in quadrant 3. All right, this other side would be square root of this one. I add them. 3 squared is 9, 2 squared is 4, 9 and 4 is 13. But what did I leave off? That's so critical, and everybody made mistakes on the last time. Negatives. You're going to do it again. Some of you just try to catch each other because you got a group. You can, like, hopefully one of you catches that there's negatives there. All right, how many of you remembered all your negatives? All right, good. Then we can actually do this. It's sine alpha cosine beta plus cosine alpha, hard to round alpha, sine beta. And then, save me some time. What are these these two fractions first? What's the first one? Negative 1/8. Second one? Negative 3 what? Root 13. Is that right or not? Okay. Cosine is adjacent over hypotenuse. I think it's negative 3. I think it's right. Isn't it? Cosine is adjacent over hypotenuse. This is the adjacent side on the hypotenuse side. I think it's right. Okay, then the next one. Plus cosine of alpha. Cosine of alpha is adjacent over hypotenuse with root 63 over 8. Right? And then the last one is sine of beta. And sine of beta, it goes back to that one, is opposite over hypotenuse. Negative 2 over root 13. All right, now do you notice that they have the same denominator, 8 root 13? So then you just have to pretty much add the tops. Negative 3 times negative 1 makes 3, plus, but then it becomes a negative 2 root 63. And did anybody knows root 63 can simplify? Root 63 is 9 times 7, and therefore 3 root 7 and you times that by the -2, final answer, this part is +3, then it's minus, because there's a negative right there, 6√7, all over the denominator, 8√13. Now I know some of you probably just didn't simplify, and you would have had 3 minus 2√63. And it's pretty much right. You just need to, like, you might have lost a couple percent for not simplifying. Okay, any questions on that one? Seeing none, I'm moving on. Then this other one, this other question down here is sine of 2 beta. And some people are asking, why is this there? It's just the definition of what sine of 2 beta is. And so now I'm going to go 2 times sine of beta. Well, beta is the blue one there. So sine of that is opposite over hypotenuse, -2√13. And cosine of beta, cosine is adjacent over hypotenuse, -3/√13. And then something cool kind of happens. The denominators multiply and become √169, which is 13. And the top becomes 12. So it's 12, because it's 2 times 2 times 3. So it's 12/13 is your final answer. Raise your hand if you had that one right. Okay, good. I know that one took a while, but do you agree that those are easier than the proofs? All right. So now let's talk proofs. I'm going to give you an easy one to start with, and you guys can see if you can prove it. Prove it to be true. That one right there. I gave you an easy one to start with. Build up your confidence before I utterly destroy it. Pause for a second. So, how many of you guys are done with this one? Raise your hand if you are, and that's most. So, tangent can be changed. Sine really doesn't change too much. I could have changed sine to cosecant, but do you get how I look over at the other side and I don't see any cosecant, and so I'm like, that probably isn't it. So, sine must be, well, there's lots of options. There's actually 3. Okay, but that's only if it's squared. If it's a regular tangent, there's 2. Options are 1 over cotangent. I don't see that anywhere, so it's probably not that. So then what's the last option? Sine over cosine. See how I kind of went through it? I know I have to change this to sine over cosine because I looked at all the other options and they weren't anywhere present on the other side. So this is the only logical one to do. Now I should just kind of see what happens. I shouldn't try to change sine also, just one thing at a time. And oh my gosh, look at that. The sines multiply to sine squared on top. And then your next step would be to say sine squared theta over cosine theta. And then that should be an easy swap. And notice me drawing arrows when I'm doing something like a total change. Sine squared is changing to 1 minus cosine squared. And then I don't have to like draw an arrow from something that just stayed the same. That's pretty obvious, right? And then I think that's it, isn't it? Yep, that's identical to that. And the proof has to be 2 exactly identical things. Oops, I forgot theta on that. All over cosine theta. There we go. And oh, and I should have a little equals all the way down. And yes, you need that. You need to have, technically, you should copy both sides all the way down. But I am okay with the double dash thing, which means like ditto, means bring it exactly down identically. All right, here is your tough proof. And it looks insane. But honestly, it's only 3 steps. It's only going to take you 3 steps. That's a classic movie quote. All right. Well, I would recommend, I'm going to tell you, just to save you time, because I don't, you might have 15 minutes to do this tomorrow, but I want you to try to finish this up in like 7 minutes right now. I'll tell you the left side's the one you want to manipulate. And once you're done manipulating it, I'm going to remind you, and I'm also going to save you some time on a wild goose chase that wouldn't have worked. How many of you saw this and right away are thinking, oh, I could put in sine squared for that? That's what I was thinking. You should be thinking that, but don't, because sine squared won't lead you to where you want to go. It brings you to a very dark and lonely snide field, almost 9 miles wide. So, anyway, I'm going to be instead suggesting you put in something else for that. I've told you another option, something you could do with that. All right, I'm going to give you some time to think. You need to fight through this. They're not automatically apparent. The 15 minutes of working on it means it isn't automatically apparent. Once you know which way to go, it only takes literally maybe 2 minutes to actually write the words. It's try stuff, think, did I get closer or not? All right, give it a try. All right, so a first step, you know that the top, quiet please. You know that the top has to have a sine 2 theta in it, right? I mean, that's what it says. The top's going to be sine 2 theta. Now, it could be that the top isn't going to have that, and maybe it's on the bottom, it's flipped or something really complicated. But I'm thinking that somewhere in here must be sine 2 theta. But what is sine 2 theta? Good, you figured it out. That's good. So, 2 sine theta cosine theta. Do you see a 2? I see the 2. Do you see a sine? 1 over cosecant. Oh, and do you see a cosine? Aha. All right. So I hope you see a 2, and this thing, which is kind of a function, 1 over cosecant, that is just like sine. So since this is 2 sine theta cosine theta, you look for it. Try to find it. All right. The other hint I have for you, how many of you have figured out what to do with this red thing? All right, if you haven't figured out by now, I need to get you done with this thing. So if you can factor it, you should. It doesn't always work, but it's a technique, especially when you're trying to get to not be squared anymore. See, like that. All right, so I recommend you factor that red one. And if you haven't figured out how those factor yet, ask the kid next to you. If they don't know how to factor this either, please both raise your hand and I will come out and show you, because you need to know how to factor. I'll pause for a moment while you process that. Okay, so here's my proof. First of all, I have to hold one side constant. I'm going to choose to hold that green side constant. I'm not going to touch it. In proofs, you can't touch one of the sides. So I told you to factor the bottom, so I'm going to go ahead and factor that now. So my new denominator is going to be 1 plus cosine and 1 minus cosine. On the top, and I should draw an arrow to that, is signifying I change that to that. Okay. On the top, this 2 times 1 over cosecant is the same as 2 times, instead of 1 over cosecant, I'm going to put a sine, because what 1 over cosecant is. And I'm going to draw an arrow to that to show that I changed that into that. And cosine is still itself. I don't need to like indicate that I didn't change it. It's still there. And then I have a 1 plus cosine theta. And you might be saying, why is there no denominator up there anymore? Because they were all 1s. After I fixed the 1 over cosecant and changed it into a sine, the denominators are all 1s up there. So now we're a lot closer to getting to our goal of the green one. Now I can change this part right here into 2 sine theta. 2 sine 2 theta. There we go. And this other one, oh, sorry, sine of 2 theta. My bad. Thank you. I was getting a little confused there. All right, the cosines, or 1 plus cosines, there's one on top and one on the bottom, so they will cancel. And that leaves me with just this turned into this, and that I don't need to, like, it didn't change, so I'm just rewriting something. Don't need to indicate an arrow to that. So there we go, and I hope that's what I was supposed to prove. Yep, look at that. It worked. Okay, equals, and I'm going to bring that down, and you need to actually copy it down exactly. Sine, you want to say 2 sine. Sine 2 theta over 1 minus cosine theta. All right. This is not just about can you prove trig identities to be true. It's using facts to prove an argument. And I hope you get that a lot of times school is about teaching you to think better, teaching you to be able to explain yourself. Because you can't just say, well, I'm right. You don't convince people by that. You have to be able to prove things to them. See, This leads to this. Logically, then that leads to that. And if you can construct a proof like that, you can a lot of times get people to see your way of thinking, get people to understand your solution. Right now, there's some engineer who's trying to convince people at Goodyear that they need to develop spherical tires. It's true. They're developing tires that are balls instead of wheels. Isn't that a weird thought? And then if I hear you, then where's the axle going to be? I'm sure that's their first question. All right. Okay. I've given you some ideas on how to study. I encourage you to go back and do old problems, watch old videos, and do your best to be ready for tomorrow. Have a great day.